Hello everyone, welcome to this video. And in this video, we're going to explore distance formula that is related to analytical geometry. As you can see on the image, that's how it works. And I'm going to use an application which is GeoGebra. I hope you learned something with this video. Hi, so in this point, we'll look at now on a given. I'm using now GeoGebra, the geometry application. So I created already 3 points here, such as point A with coordinate of 2 comma negative 2, point B with negative 1, 2, and then point C will be negative 1, negative 2. Now, let's look at now if we could get now the distance between C and A. Now, as you can see, if you were going in a horizontal, you started with C and then going to A by unit. So we can say that, but you can count that by points. So this would be 1, 2, 3. So therefore, we could look at it as 3 units. It's much easier so we could say that CA is equal to 3 units. So we have now 3 units here. So that's good. So it's much easier because it's horizontal. Now let's go on a vertical approach. So let's look at now the distance between B to C or C to B. So if I could start with B, so I have 1, 2, 3, and 4. So if I would have a segment from B to C or C to B, so I have now 4 units. So I could have now a text there. So I have there BC is equal to 4 units. So it's much easier for us if we have now the vertical and horizontal. However, now the question is how to get now the distance between B and A or AB. So as you can see, this is now the distance. Now, as you can see, the triangle that was being formed is a right triangle. So if it's a right triangle and you have now the distance of the two legs of the right triangle, you can use now the Pythagorean theorem. So if I would have here, so let me have now a Microsoft Word so that I could have it. So let me just give it a little bit bigger so that we could discuss that. So, and you can see now this one. So if I would put it here so that you would be simultaneously, you would see. So let's go to the distance between B and A, right? So we know that BAC is equal to 3 units, and then BC is equal to 4 units. Now we can use now the Pythagorean theorem where they say it is C squared is equal to A squared plus B squared. Oops, let me have that properly. So if you want to get now the hypotenuse, in this case, the hypotenuse is BA. So we could have now C is equal to the square root. Am I right? Square root of A squared plus B squared. Now, expediting the process, let's have that. So let me just copy the equation so that it's much easier for me to look at that. So we have now C squared is equal to A squared plus B squared. So it's much primarily you'll have there any of the two would be like you have now 3 squared plus 4 squared, right? And then what do we have there if we have that C is equal to square root of 9 plus 16. Then getting the sum of that, so we have now C is equal to, let me have that. So it's much easier for me. So we have now 25, and therefore, because we're finding out distance, so it is a scalar quantity, so that would be 5 units. So that's easier. However, if the case is that we're given, example, we don't have point C as a reference, so that will not get the the units or the 3 units for CA. Assuming that the given is only B and A, how we're going to work that out? Now, the thing is that we want to get now the distance between B and A in a sense that the given is only the coordinates. Now, how are we going to work on with that? Now, there is what we call the distance formula in analytical geometry. Now, in analytical geometry, you use now the coordinates. So you better get now all the distance from x, the square of the distance, the difference of the distance from the x coordinates, and then add to the difference of the distance of the y coordinates. So in a formula, we have now the square root of x sub 1 minus x sub 2 squared plus the difference. So we have now y sub 1 plus, no, minus y sub 2. Then you make it square. Now, let's look at this one. This is now what we call now the distance formula. Okay. Now, in the distance formula, assuming that the given coordinates are b, which is negative 1, comma 2, and we have now a, where 2, comma negative 2. So assuming we don't know the coordinates of C and the given is only B and A. So we have the confirmatory that the distance between B and A is 5. Now, how are we going to get the distance using now the coordinates? Now, it's much easier if the distance, because we use now the Pythagorean theorem, and the concept in the distance formula in the analytical geometry is the Pythagorean theorem as well. Now, working on that, as a suggestion, you go on assignment. So I assign now x sub 1 would be equal to negative 1. And then I have now y sub 2. So that will not get, y sub 1 rather, would be 2. Working on the coordinates of point B. While my x sub 2 would be equal to 2, comma, and then y sub 2 would be negative 2. Makes sense. Now, working with the formula, let's use this formula so that it's much easier for us. Let me just copy that. So, if I have now x sub 1, so it's much easier for me to substitute. So, I have now negative 1. And then I have now my x sub 2 would be 2. So, be careful when you're substituting it because the sign might get confusing. And then 2, and then this would be negative 2 as your, and that would be the substitution. Now, having that, when you substitute now, you can now process it. So, negative 1, this would be negative 3, if I'm mistaken. And then 2, this would be 4. That makes sense. So, I have now 4. So, I can have this one. And then I have it here. Let me just make this a little bit simpler so that it will be continuous. So, if I have that, this would be the square of 3, that is 9, I believe. And this would be 16. And then when we add it up, I think this would be similar to the first one that we're working. So this would be 25. And I believe we got now the answer D is equal to 5. So that's how it works when you look at now the distance formula. This is the inspiration if you know the distance. So it was formulated using the Pythagorean theorem, which is D is equal to the square root of the difference of the x coordinates, and then plus the square of the difference of the y coordinates. And then in the problem, the answer is 5. Thank you for watching this video. I hope you learned something about distance formula and how to use GeoGebra as well on that manner. I hope you can look at that. That the Pythagorean theorem is where the distance formula came from. And I hope if you have any question, you can drop in your question at the comment section so that I could answer it. Thank you for watching and have a great day, everyone.